remember about optimizing hard disk drives in Windows systems is the fact that a mostly empty hard disk drive is going to perform a lot better than a mostly full hard disk drive. And it has to do with the way the NTFS file system fragments files on the hard disk drive. The more full the hard disk is, the more fragmented the files will be, and the more time it will take for the read-write heads to both write information to the hard disk and to read information from the hard disk drive. Therefore, you want to keep your hard disks as empty as possible. Now, in this system, let's take a look at our C drive. Notice that this is just a lab system, so it has just a tiny 40 gigabyte hard disk drive installed in it. This is much smaller than you would see in a production system. The key point, though, is how much of this disk is currently being utilized for file storage. Now, notice that it's about 40 gigs total size, and of those 40 gigs, about 25 gigs are still free. We're well under 50% utilization on the hard disk drive. We're actually good. This is unusual, however. This is a lab system that doesn't actually get used for much of anything. On a real system, in a production environment that an end user has been using for months and months and months or even years, you'll see most of the time that the utilization bar is probably right up around here because end users use disk space like water. They just use it, and you can never have enough. That's because notice over here that on our system drive, we have a folder called users, and within users, we have all the user profile directories for each user on the system. So when this user downloads video files from the web or music files from the web, well, guess where those files go? Right on our C drive. And so the C drive always gets clogged up with files. Now, this principle applies to not just the system drive, but any hard disk drive on the system. Anytime you see a hard disk drive that is being overutilized, it's going to perform poorly. So what do you do in that situation? Well, you have two different options. One is to go through and delete a lot of the files that aren't actually needed anymore, or you need to migrate to a larger hard disk drive. We're going to kind of take a look at the first option in this demonstration. Now, understand that Windows provides a utility called the disk cleanup utility that will go through and delete a lot of the unnecessary files that are created and stored by the Windows operating system itself on your hard disk drive. And there are actually sometimes a lot of them. To do this, you right-click on the drive and then click on Properties. And then you look at the General tab. Now, notice on the General tab, it provides us with disk utilization statistics. It tells us how much space is currently in use, storing files on this volume. And here's how much free space is currently available. And as we said earlier, this drive is in pretty good shape. It's not being overutilized. Down here, we see the total capacity of the hard disk drive. And we also see the disk cleanup utility. I'm going to go ahead and click on that option. And when I do, it's going to go through and analyze the hard disk drive. It's going to look for files that Windows has created that aren't actually needed anymore and that can be deleted from the system. Over here on the disk cleanup tab, you can see a list of different file categories and how large the files are in each of these categories. We have our setup log files, we have our downloaded program files, temporary internet files, offline web pages. Down here we have the recycle bin, some temporary files, and our thumbnails. Now notice that not all of these files are selected by default. If I'm cleaning up a hard disk drive, I usually go through and mark all of these because usually you don't need any of these files. They're just taking up space. Now, you'll notice that some categories of files are bigger than others. Notice that our setup log files consume a whopping 364 bytes, really almost not even worth worrying about. But down here, our temporary internet files are consuming 141 megabytes of disk space. And on this small hard disk drive, that's a consideration. Now, these temporary internet files are saved by your web browser. Understand that whenever you use a web browser to go out on the internet and browse the web, your browser will cache a lot of the content from these websites locally on your hard disk drive. That way, the next time you go back to that same website, instead of downloading those same files again, it just pulls them from your local hard disk cache, which speeds things up. So while that does improve the performance of the web browser, it also clogs up your hard disk drive with a lot of junk that you don't need. So I'm going to go ahead and clean out all of my temporary internet files. Also notice down here that the recycle bin has a lot of files in it too. It's got 203 megabytes of files. So between the recycle bin and our temporary internet files, we have a fairly substantial amount of disk space that can be freed up. Down here, notice it tells us how much disk space we're going to gain on this hard disk drive by going through the disk cleanup process. We're going to free up about 358 megs of files. Now, There are other files as well that we can clean up. Notice down here, there's an option to clean up system files. These here are kind of end user related files. They're created for the most part by the end user as they go about their day-to-day work. However, there are additional files that are maintained by the Windows operating system itself that are temporary in nature and don't need to be saved on the system long-term either. We can click this option right here to clean up those files as well. We'll wait just a minute while it analyzes and finds out how many files can be deleted. So now if we look under files to delete, we have additional categories of temporary files that we can choose to delete. So I'm going to go back through and mark these options as well. Notice we have a category now called Windows Defender, which contains non-critical files used by Windows Defender. There's about 18 megs of those files. We'll mark the other options that we marked earlier. Notice we have a new category added here called System Error Memory Dump Files that we can clean up. We have device driver packages. Currently, we don't have any that can be removed. We'll mark our recycle bin once again, along with our temporary files. And notice down here, we have another category added called temporary Windows installation files that we can also clean up. So by using the clean up system files option, we added about another 20, 30 megabytes of files that we can clean up. Not a lot, but every little bit helps. Go ahead and click OK. And we're prompted whether we want to actually delete these files. Yes, they're just temporary junk files. Let's go ahead and clean them up. And then we wait for a minute while the disk cleanup utility cleans those files off. And this sometimes will take a few minutes to complete. I'm going to go ahead and pause the recording and we'll come back when the cleanup process is done. All right, the disk cleanup process is now complete. And notice that we have reduced the amount of used space on the hard disk drive. Now, as you can see here, I did not clean up a whole lot of space. So if this disk was overutilized, as we discussed earlier, then I might want to go through my user profile directories and have the users clean up any unused files that they no longer need, or more than likely just migrate to a larger hard disk drive. So that's disk optimization task number 1, cleaning off unnecessary files in the file system. Now, if we go over here to the Tools tab, there are other options that we can use as well to optimize our hard disk drive. One is called error checking. Understand that a standard hard disk drive is a mechanical device. It stores data magnetically on spinning platters, and there's gears involved, there's electric motors involved, and as such, it is possible for this storage device to wear out over time. Specifically, it's possible for the surface of those platters to become damaged or wear out over time, and they will no longer store data correctly. We can use this option right here to check your drive for file system errors. To do this, we can come over here and click on Check. Notice that we're prompted that we don't need to scan this drive because Windows says, I haven't found any errors on this drive in the past, but you can still scan the drive for errors if you want to. Back in earlier versions of Windows, you had to run this file scanning process manually. With newer versions of Windows, this process is so important that the Windows maintenance function that you can configure within Control Panel will automatically run this check on a regular basis for you. Therefore, that's why we're getting this message saying, hey, I've actually been looking at this drive and it looks good to me, but if you want to check it out, knock yourself out. And we'll go ahead and do that. To do this, we can come down here and click on the scan drive option. And when we do, the surface of the hard disk drive is scanned and it's looking for errors. It's going to look for physical defects in the surface of the platters of the hard disk drive. And it's also going to look for file system errors because remember, the file system is implemented as software within the operating system kernel. And therefore, it is possible for errors to occur, which causes data to be stored incorrectly, or maybe data on the surface of the platters to become disconnected. For example, we may not know which file name a particular file fragment is associated with. This disk error checking utility is going to go through and look for those kinds of errors, and it's going to automatically fix them for us as well. Now, in newer versions of Windows, this is done automatically. In older versions of Windows, you had to explicitly tell the error checking utility to try to fix errors when it found them. As you can see, this is going to take about 3 more minutes to complete, so I'll pause the recording and we'll come back when it's done. Okay, the scanning process is complete. The drive was successfully scanned and no errors were found. We like that. We can come down here and click the Show Details button. And we can see more information about the scan process. I'm going to go ahead and expand this up here so we can see more information. You can see that I have the scan event that occurred today. This is today's date. And down here in Event Viewer, we can see the results of the scan that provide you with a great deal of detail as to what was scanned and what errors were discovered. Go ahead and close Event Viewer, and we'll close the error checking utility results. The last thing we want to look at in this demonstration is how to defragment the hard drive. Understand that the NTFS file system fragments files as it saves them on the surface of the hard disk drive, and it does this to use disk space most effectively. However, by doing this, it also decreases disk performance because the read-write heads, in order to write information to the platters, the read-write head has to search around and locate unallocated areas of the disk and save information there. And then when it wants to read a file, it's got to hunt all over the surface of the disk trying to find each of the different fragments of a given file so it can reassemble it and send it up to the operating system. Your drive will actually run a lot faster if you can take all those disparate chunks of those files, all those file fragments, and move them as close together on the surface of the platter as you can. That way your read-write heads don't have to hunt all over the surface of the platter to find all the pieces of the file. They're all in one location. So to do this, we click on Optimize, and then we can select which disk it is that we want to defragment. Right now, the C drive is selected by default. Now, I will point out that you don't actually have to do this manually very often. You may need to. However, on modern versions of Windows, the defragmentation process is run automatically for you on a schedule. Now, in older versions of Windows, that was not the case. You did have to go in and run it manually. And if you ever ran into a system that hadn't been defragged in like a year or two, and I have had that